Serialization. What the hell is it, and what has it got to do with ZooTools, Yellow, and Hive? Before I explain it, let's go back a little bit and understand myself a little. I haven't always known what serialization is. I haven't always scripted. I wasn't always into tech. So talking to devs, talking to TDs, talking to engineers, when I was in a production environment, when they talked about things like serialization, it made absolutely no sense at all. They lost me immediately. So what exactly is it? And the way they basically expressed it in really simple terms for me was it's the notion of saving and loading. In terms of Maya, and something that we do all the time as artists or as readers or TDs, is saving and loading a scene file. In Maya, you would go File, Save, or Save As, and then you would go Open or Import and Export. This is basically serialization. That's all it really is. You're taking a scene and you're saving it out. Now, understanding that basic concept, for me, that was a light bulb moment for me. That was a moment that everything started to click. If the notion of serialization and deserialization, which is the notion of saving and loading, then wouldn't that mean that you could break that concept down at a more atomic level, or aka a smaller kind of concept? So what if you could save and load a Maya node? For example, if we go into the node graph, or node editor, and we take any one of these nodes in Maya, couldn't we just save and load one of these nodes? We can do that directly in Maya through saving and loading, or importing and exporting. But that would mean saving and loading a Maya file. And that comes with problems. You can do that, but you have to basically deal with the caveats. Now, as someone who's been a pipeline TD over the years, I know the kind of problems you get into. Plugin requirements being one of them. I absolutely hate them. They're a plague. And no matter what you do, you can't get rid of them unless you edit the file and deal with some code. And that's an absolute nightmare to deal with. And when you have millions of files across your studio, it's a massive nightmare. So one of the things that I wanted to deal with when I started developing ZooTools 2.0 and Hive back in 2017 was I wanted to avoid using Maya files as much as possible. But it wasn't just Maya files that I wanted to avoid. It wasn't just the notion of, hey, I don't like Maya, now it saves and loads, let's rewrite it. It was mostly about representation of what I wanted to do and make it work in many different situations. I wanted to make it work so that I can reduce the amount of code that I had to write that was basically mundane boilerplate code, the stuff that I didn't really need to write. In Hive, that's exactly why we use serialization, or at least the initial reason. Later, that turned into other reasons, like being able to save or remember what you did last, being able to recover what you did, being able to save templates, being able to create a default spec of your actual component, or what we call definitions, which is a serialization of your component. When Hive was originally built, when you had to write a component, there was no code. There was a notion of just, hey, create the nodes like you normally would in Maya. Go to the file menu, go create, and create what you need. Or go into the node graph and create the nodes, like a mult matrix. Connect all the dots, set all the settings, and then run a script. Like, just select everything and run a script, and we'll serialize it, aka save it out. We didn't save it to a Maya file, we saved it to JSON data. And that itself is really easy to understand when you start looking at it. So let's have a quick look into it. Here we are in PyCharm. And what you're looking at right now is the definition of a component, more specifically the VChain. the VChain has almost all the information relating to the component. Now there's the VChain, but there's also the arm component, leg component, spine. The question is, how much are we serializing or saving? And that's kind of difficult to a certain extent to explain every bit of detail relating to it. But let's look at the very broad concept. Here we have essentially a knee, or the knee joint, or mid is what we call it because we generalize it between the arm, the leg, and a standard two-bone IK. We have the shape, which is the CV shape. It's the shape that the animator will see. And if we really crack this open, it gets kind of scary at first. And you start to see that we're actually storing the actual shape node, the name of the shape, what kind of overrides you have for the color, the outliner, the actual knots of the CV points, the degree, the form, and the matrix. If we go outside the shape and start looking at other things, you'll see something that I've talked about before, which is unique identifiers, or ID in our definition. All we're doing is taking information from the Maya scene and saying, hey, what are your properties for this particular node? And give it me back something that I could store on disk, aka your file system, that I can recover at a later date or load, and aka serialization, deserialization, I should say. Now there's other things that we store, like the Hive type, transform, like translate, rotate, scale, and just so you have a bit of information about what the actual translate, rotate, scale is in what space. That's actually in world space, not local space. And that's a really important thing to grasp when you're looking at this. You have the shape transform, which stores the location or the transform of the animation control. This is not the pivot point. This is the guide. This is the actual transform of your control shape that you see as an animator. For example, it's the local transform of what you see for this control. But it's not the pivot location. It's the actual transform inside the guide. So if we go back to guides, and we have a look at how it's constructed, this control that you see here is the same one that you see as an animator. This transform you can put anywhere you want and scale it, but it won't affect the transform that the animator will see. That's what the pivot is for. But all this information is serialized into exactly the same data structure that you just saw. This. The shape transform is the location of just what I just changed just now. These translate, rotate, scale, rotation order is everything from the pivot point. That affects your animator. SRTs is the transforms that are above that control or guide. In this case, the SRTs on a guide layer is relating to the actual guide, not the animation control. Then you have the local matrix and the world matrix. Now keep in mind, there is currently work being done to simplify some of this data, but most of it will stay. Things like the world matrix and the actual local matrix will probably disappear. The translate, rotate, scale will actually stay, and is likely to stay in world space. And it's something I'm making that is going to make this process simpler when it comes to construction of your component. Because one of the things that is a slight caveat, but it's also one of the more powerful things and why Hive is the way it is because we basically create this data ourselves. When we create a component, we create the data. And there's different ways of doing it, like copy and pasting the template data into a definition. That's something I'll talk about another day. Now in our definition, which is just a description of your component, describes more than just the guides. It stores your settings, like whether this has stretch. But if you have a look at the data, the information relating to this particular setting, You'll see something if you've come across it before from the coding point of view, whether you're working with MySCMDS or MySAPI. And there's certain kind of properties, like whether that property or that attribute is an array, whether it's an actual element or a child of a compound attribute, whether it's displaying in the channel box, whether it's keyable, whether it's an element of an array, and it's basically all these properties, all these values that need to be saved and loaded. This allows us to store and create attributes at any given moment. You don't have to worry so much about how you translate this information. It is the job of Hive to take the data that you have in the definition, to translate it or deserialize, then translate into a Maya scene graph. Now, in this case, we're creating attributes. Underneath the hood, it's creating an extra node, which is going to be a meta node, which we've talked about before, and we've even gone through creating our own. That meta node will then have this attribute. The data on here expresses all that information necessary. Now, not all this information is necessary to actually be able to do this. This is something that is changing in terms of better optimization of the data, compression of the data, but it's something that's going to happen over multiple versions of Hive. But it's not just the guide, it's not just the settings of the guide, it's also the input layer, the DAG system. So the upper, the end, IK, if you keep jumping in, you'll start to see some common settings, rotate, translate, so on. That can go into the output layer and so on. That just repeats itself for every single meta or Hive layer, which is, again, a meta node. It has a serialization mechanism to say, this is how I want to serialize my guides or save my guides. It also has this mechanism to load those guides or deserialize them. In Python, serialization can be very simply recognized as dictionary. My var equals a dictionary. And I have an attribute called myAdder. I can then just store a set of properties or values relating to it. Oops, not then. I can just go value equals 0. And I can give it a type. I can say this is a float. This is a notion of serialization. It's the basic concept of it. And if I save this to a file, I'm then storing that so that I can later retrieve it. This is the basics of how Hive works. This is also the basics of how most of ZooTools is designed. There's many other advantages to this, like remote access, so you can send and receive information from an external database. When you start to understand these things, you start to understand the concept and the power of what you can actually do as a dev. And the main things like working with databases is just exactly what you see on screen. A database is this. It can be represented as this, seen as this. It's just a set of JSON files. It's obviously going down the deep end, which I'm not going to go down, but it's something I've done as a pipeline developer when working with databasing and data modeling and writing my own web services. It all comes down to it. And it's also made massive improvements in the way that I work as a developer. So understanding serialization is really important. Now, I'm not going to get into everything relating to how Hive works in serialization. That's something I'm going to leave to the next video, because that's going to get a little bit more technical and understanding the flow of how the code works and what it actually entails. And that's when we'll start to look at basics of code and basics of how a Hive component is made up and how you actually start constructing it. It doesn't mean that we're going to create our own custom component right now, but you'll start to see how it's made. You also start to see some of the problems that we have in Hive, the limitations, and you'll start to see the advantages. Well, I hope. You'll also see something that we're making changes to that is going to be really handy. If you don't know how to use it and you don't use it, you're costing yourself a lot of time. But once you know how to use it, it saves a drastic amount of time as a developer. And when I say developer, I mean writing your own custom components. And that all comes down to serialization and deserialization. More specifically, if I go into Maya, and wouldn't it be great as a developer when I'm writing a component to be able to make changes to my graph, like a DG graph, like the math behind something. So for example, if I go into the rig and I show DAG objects in the outliner. Now I'm just going to go and say, make sure the black box is off first. And I'm just going to type WildStar, a wildcard in the filter, and I'm just going to type in input. You've got a bunch of different nodes. All I'm going to do is select one of these inputs, and I'm going to select essentially the corresponding output, wherever that went. Don't really need to worry about selecting the output. Let's just go with the input. If we take this and just expand the entire graph like that, so we can just see everything, you can see that we have all the meta nodes there. But if we look at this node here, which is going to be the other important one, and we have a look at this node here, wouldn't it be great if we could do our math or do our node graphs directly inside the node editor and be able to just save them out and then load them back up, right? We want to be able to create a motion path graph and be able to use it. For example, we're using a motion path node for our twists. I'm not going to explain why. That's something for another day when it comes down to the actual bendy system. But wouldn't it be great if I could actually do this? If I could drop down, let's say, an A matrix directly inside of our rig, to make some changes. Let's say I want to just bypass this node, do some testing, and so on. Find out it works and does exactly what I want, and then be able to save this section of this node graph to disk and load it back up, and then reuse it as many times as I need. This is something that we've built in Hive, so that you don't actually have to write these node graphs in code. You still have to write the creation of those node graphs. You still have to write the code that will actually create the connections to the inputs and the outputs. But we create an interface in code in Python to simplify this process. As an example, I wrote a little bit of code recently to be able to do dynamic or live auto poll vector. One of the concepts we do is place the poll vector all the time. One of the things we've been wanting to do for a while is be able to interactively place that poll vector, not by hand, but let the system do it. So one of the things I started writing recently, and this brings back the concept and the power of serialization and deserialization, is if I use what's called DG graphs in Hive. You can think of these as compounds or node compounds, nodes within nodes, being able to save them and load them. What I'm going to do is create this graph. Ignore the warning. Now, I'm just going to go down the bottom here so I can see it get generated. If I create the IO nodes, what I just did right here and now was generate this entire node graph purely from JSON data. So for example, if I now just delete that graph, now I'm just going to not create the last one, but if I create these nodes, you can see that we just generated all this. Now this auto poll vector is actually sitting inside this folder in Hive as a DG graph. If we go right to the top of the file, we have nodes, and then we have all the data relating to that node. It means all the attributes that we need to serialize and load. It means all its current values when we actually store it. So we just recreated an entire node graph, and we can do that as many times as we need. And this is exactly what we're doing in Hive for that bendy system and our twist system. And we're upgrading all our other components one by one to do the same thing. This allows us to do something more interesting, like being able to make modifications like default state, making changes to connections. Instead of wanting to connect it to here, I might want to double it up for some reason. Not that I want to in this case, but I could. But if we have a look at this a little bit more closely, I would like to be able to connect this really easily in code. So for example, if I just encode here, go scene graph, and just list the inputs, what we have here is all the inputs into this graph. Right, this is what I'm talking about when it comes to serialization, but also wrapping that serialization in kind of a framework so that you can work with it better. So you don't have to worry about how the data is formed. But understanding how the data is formed makes you a better developer, makes you able to make more informed decisions on your development process. So we have things like connect to input. So if I know what the input of the graph is, like for example, mid-world pos, if I look at the actual data here, it says, well, mid-world pos input, which is an attribute, connects to the world translate, connects to the offset vector and the mid vector. There is no input here. I don't see it. What these are is essentially attributes on other nodes. So in this case, I can use that data I stored on disk and load it back up to create an interface for you, like I just did now, which generates an input node which contains all your properties, which you just saw here, directly as attributes. Created all the connections to everything it's meant to be connected to. If I go to the far right, I do the same thing. The world matrix is connected to the object space. This allows basically conversion between coordinate systems or different spaces. For example, I'm using the world matrix output that I've calculated for the pole vector, and I'm multiplying it by the parent inverse matrix, which gets me back into object space. Obviously, I'm not going to go into math in this, and matrix math, vector math, and so on, but the idea is that once you understand some core concept of serialization and the power of it, you can take it even further. And you can store and load Maya node graphs yourself. In this case, we're storing parts of our node graph in JSON form, and then in code, we can recreate them as many times as we need. And Hive has functionality for our meta system to be able to track all this information. And it also means that in your animation rig or your actual character rig, you can do the modifications to the node network like your math. And in code, you can basically save those changes out again. And those changes get recreated, reapplied on top of these JSON data. It gets saved as a file. Then in code, you can do something like this. Same thing I just did in the script editor, but I just created a little wrapper for this particular situation for the component. I create a graph. I then create all the inputs to that graph and all the outputs to that graph. I can set attributes, and it's doing it on multiple attributes at a time. It simplifies the amount of code because I don't have to create code anymore that creates the nodes, nor do I have to worry about the individual connections within that graph. I can just do it like this, load it and save it as a graph. And that gets even more complex when it comes to things like Bendy. It's loading and saving large graphs of nodes. This is something I've had in the books or on the books for Hive for a very long time. And it all goes back to something that I built back in 2017, and that's the notion of serialization and deserialization of node graphs. So understanding serialization is something really important because understanding that, you start to understand how Hive is actually designed. You start to understand how the build system is designed. You will start to understand how to write your own components. And when we talk about things like definition and templates, you will start to understand and make sense of how everything is actually built and what you're working with. So if you come down and start to have a look at things like deformation and setting up animation attributes, you're actually working with data. You're not working with the Maya scene. For example, I'm getting access to the definition here. I'm then seeing if it has stretch. Then I'm accessing the rig layer. And then I'm deleting those attributes if it doesn't have stretch from the animation attributes. But again, I'm not touching the Maya scene. This means that I don't even need the rig in the scene to be able to manipulate it. I can do all this modification without touching it in the Maya scene. And there's something really important here that you probably haven't noticed, and that's intentional. When in Maya, in the Hive UI, which is the same thing in code, when you switch between these build modes, there's something really important to notice, and that is if you're in polish mode, as I said in previous videos, the guides don't exist, not anymore, right? So if we go into the component layer, into any one of these components, there is no component layer, which is crucial because that contains all our pivots, that contains all our information to be able to create our rig in the right locations. You can also define all our properties like aim and the up vectors for our auto element, and many other things like our control shapes for the animation team. But the interesting thing is that if you go to skeleton mode, and in my case, I just need to display it, the guides still don't exist. They haven't been recreated or anything. The skeleton has been updated. That's because it's not using the guides in the scene. If I go into rig mode, normally you would expect this to fail because I need to be able to place my rig relative to my guides. I need to know where my guides need to be placed, like my controls. I need to know what properties you set. If did you have has stretch in the UI, you have stretch. I have has stretch turned on. In code, I'm accessing has stretched, but the guides don't exist. But in Hive, when you go to rig mode, it doesn't matter if the guides exist or not, because the way you write code in Hive is not through the scene. It's through the definition or the serialized data of your rig. And as we progress in Hive, as we make changes to how it works, what we're doing is reducing the amount of code you actually require to be able to build your rigs and be able to translate certain aspects of your rig into the scene. Because we can't, at this current stage, we don't manage everything. Not for you just yet. It's very complex to manage an entire node graphs in a dynamic way. So we have a balance that we have to provide you between what is driven through data and what is driven through code. And no matter what we do, we always need both. How you actually do it is another story, which we'll get into another video. You thought I was going to not do that, but this is really important because when you write your code will fail if your guides don't exist in the scene and you're trying to access it. That's why, for one reason, it's one of the reasons why Hive actually uses a definition. That definition contains your most up-to-date information relating to your guides. That latest information could come from a template, it can come from the scene, you can even write it yourself directly in code, and then provide that to the component to be able to say, hey, this is my updated data. Can you build the rig with this information for me? This is incredibly handy because this allows to do some other things as well. And it's something that I've been working on. Well, I haven't had much time to work on it, and I wanted to show you something that we are trying to do to help improve the process as a developer, not as an artist. This is a new UI that I've only just started, and I want to give you a bit of a sneak peek of what I'm trying to work on to help improve the development process, not just for myself, but for anyone like yourself who wants to write their own. What this is a component editor. The idea is to express as much as it possibly can directly in data form. This allows for things like UIs to exist without the actual guide being in scene. In my case, I can load up the God node or any component, and I can see its raw data. Ultimately, this UI would get upgraded quite extensively to be able to do things like creation of guides, deletion of guides, and a range of other things. The idea is that you wouldn't have to touch the data at all. You'd be able to do this purely for the UI. But that's going to take us some time, so hopefully you can be patient with that. In our next video, we're going to start looking at how serialization, deserialization, and, well, to keep the terms going, synchronization works in Hive. So hopefully you learned something, and I'll see you in the next video.